talk about is health hazards in construction, and Dave and Jennifer's presentation, they talked about how about 5% of fatalities in construction are from exposure to hazardous agents, and I just wanted to provide some context that that's a low number, but like Brad pointed out in his program material, a lot of probably most of the health hazards encountered in construction, they don't result in illness until much later in life. So that 5% is just a very small piece of the pie and would represent things like if someone collapsed from, elevated vapors or gases in a confined space. So again, who we are a research arm of the Building Trades AFL-CIO, and we conduct research aimed at improving quality of life for construction workers and also do training. And since the early 90s, we've served as a NIOSH construction center, which, as Jennifer alluded to, are kind of like one of the third legs on the three-legged stool for NIOSH. And if you've worked with people from NIOSH, they really are about as dedicated and intelligent a group of people you could work with, so it's a good thing for us. So in addition to them, we work with different university entities and also with folks from the construction industry, contractors, building trades unions, and so on. We've got a pretty large training program in addition to our research program, so we get funding from National Institute for Environmental Health Science for hazardous waste training. Also, we're an OSHA training provider and do some disaster response training. So just in the way of background, I think you all are aware that construction is a very dangerous industry. In terms of fatalities, we lose somewhere in the neighborhood of about 1,200 workers a year, and that number's remained pretty static for a number of years now. But in terms of occupational disease, we don't really have a good handle on that, but it's estimated that about 50 to 60,000 deaths a year result from occupational illness in all industries, and that by some estimates, that would place occupational deaths as the 8th leading cause of deaths ahead of motor vehicle accidents for the general population. And cost estimates for the whole toll of disease and injury is somewhere in the area of $23 billion a year. So I had actually used this chart in another presentation where I was trying to describe how many layers of management there are in construction, how communication can be a challenge, and that's still true, right? That if you're a project manager and you want to get the word all the way down to the laborer or the carpenter down in the field, you're generally having to go through multiple layers of management. But the other reason, and probably the main reason I put it up here for this venue, is that what we found is that construction owners, clients, really can have as much or more leverage in terms of impacting safety and health on a construction job than say even OSHA. Obviously OSHA is important, but usually by the time OSHA gets out there, something's already happened, and sort of a reactive approach to safety. But if we can get owners like Department of Transportation agencies to specify certain safety and health programs, then it seems like we're more effective in really making a change. So it's really nice to be able to present to a group like this. So one of the big problems in construction, it's continued to be a problem for many, many years, is silica. And New Jersey, Ohio, and Michigan, 3 states that keep track of silica deaths, they identified 576 cases in that 4-year period between 93 and 97. 45 of those came from construction and 12 of those from heavy and highway construction. Some things to keep in mind: in February, there's a new OSHA standard that's expected to come out. There's also a special emphasis program in place right now, which means OSHA would be targeting silica as a hazardous agent to cite on. And I don't know if did OSHA talk about their new severe violators enforcement program. There's a new program that it's for contractors who kind of are willful repeat offenders of certain standards, and it targets certain regulations and hazards, and silica is actually one of the agents targeted by that program. So as far as the health effects go, I mentioned silicosis, which is a fibrotic lung disease, which makes it very hard to breathe, once you have it, and if it gets bad enough, you're having to walk around with an oxygen bottle all the time. Silica is also associated with elevated lung cancer risk, and what they call COPD, chronic obstructive pulmonary disease, which is something very similar to asthma. And that's something that's been associated with dust in general. And then things we don't hear as much about is autoimmune disorders like rheumatoid arthritis or scleroderma, which is a overproduction and accumulation of collagen throughout the body. And also there's associations between silica exposure and TB. So the numbers I just gave you, they, obviously to those 500 some odd people, it's a big number to them, but it may sound relatively small compared to some other causes of death. But when you look at, there's another measure that they use at NIOSH or at CDC, and that's the years of potential life lost. And there was a piece that came out in this publication, Morbidity and Mortality Weekly Review, a couple years ago that said that there's an estimated, well, first of all, the number of silicosis cases are going down, but the number of cases among younger workers is going up, which is kind of disturbing. And that there are an estimated 3,600 to 7,300 new cases each year. And of the 46 industries reported, the greatest years of potential life loss were in construction. So on average, the people dying of silicosis in construction were losing about 10 years of life. So that's kind of a significant thing right there. Now, epidemiologists and people who are trying to figure out what the patterns of mortality are within a particular group, they use something they call a proportionate mortality ratio. And what they do is they compare the ratio of deaths attributable to a certain cause, that proportion to a comparable group, very much similar. And there's a ratio of the proportion of that population to the general population. If you've got a PMR greater than 100, that's an indicator that there's something going on with that particular group. So in construction for silicosis, we see PMRs under age 65 well over 300. And then when you look at the trades within construction, the ones that stand out with the highest PMRs are painters, bricklayers, and laborers. Does anyone have a guess why they think painters might be among the highest? What was that? Well, one of the reasons is we think is because of abrasive blasting. They do the sand blasting. A few years ago, we had done some exposure monitoring, and the data we collected kind of paralleled the exposures. Our exposures paralleled that stair-step mortality pattern I showed you earlier, and that the painters had over 500 times the NIOSH recommended exposure limit for silica. The bricklayers were up to 24 times the NIOSH recommended limit, and then the guys involved in road milling, operators and laborers, were up to 12 times the recommended exposure limit. So for painters, they really have sort of a double whammy, because they've got the silica. The silica can be in the paint, and it also can be used in the abrasive, along with other heavy metals and things you'd find in paint or abrasive material. So they've got it coming from all ends. A good resource you might want to look for on the OSHA website is this new publication, Controlling Silica Exposures in Construction. It's a nice publication, got a lot of information about what you'd expect to see in the way of exposures, and then ideas for how to control them. Another illness I'm sure you're all familiar with is asbestosis, and this continues to be an issue in construction. Looking at PMRs for construction trades for asbestosis, you see again very elevated rates, particularly among installation workers, boiler makers, plumbers, pipe fitters, and also elevated rates of lung cancer. And when you go and look at the patterns of citations, I actually I had done a presentation on OSHA citation of health hazards in construction, and as follow-up to that, I'd called the National Enforcement Office and asked them what were the top 3 citations they issued for asbestos and for lead, because these were 2 things that were heavily cited. And the thing that kept coming up was insufficient training, lack of initial exposure assessment, and then not complying with the prescribed methods of compliance for these tasks, because the asbestos standard is a little unique in that for specific tasks they specify what sort of controls you're supposed to use, and apparently one of the big violation sources is where they're not following those procedures. Just some more health effects information. This shows some chest x-ray data from Department of Energy weapons sites involving construction workers, and in terms of abnormal x-rays, again, we see real high numbers for asbestos workers, plumbers, millwrights, iron workers, boilermakers, and so on. Another thing that continues to be a problem is elevated blood leads, and typically you would consider anything over 25 micrograms per deciliter an elevated, occupationally elevated blood lead. So if you're seeing something over 40 micrograms per deciliter, now you're seeing like very heavily, that's the highest group that you would see. And when you look at Massachusetts, which is one of the states that has a better blood lead registry system in place, you see that in the more recent years, the majority of blood lead cases greater than 40 micrograms per deciliter are in construction trades like painting and de-leading and other trades. So that continues to be a problem. So in terms of health effects, in general, in the general population, we're now seeing levels at about 1 to 2 micrograms per deciliter. Back in the days when we had leaded fuel, it was up more like 10 to 15 micrograms per deciliter of blood, but now we're down to much lower levels. And you know, a lot of the metals, you actually can find them in nutritional supplements. So at very, very low levels, they're actually essential nutrients, but at high levels, they're toxic. But in the case of lead, there's no value at which it's considered good news. It's bad news at any level. And the principal health effects at low doses are heart-related, kidney, reductions in cognitive function and reproductive hazards. And this, I won't go through this whole chart, but you can just see that at very low levels, you have possible health effects related to cardiovascular and reproduction. And then as you go higher up, the possible becomes not possible anymore. It's a very well-recognized association. Some of the trades that are at risk for lead poisoning are painters when they're doing abrasive blasting, iron workers doing rivet busting, torch work, which is common on bridge work, laborers doing torch work, demo construction, carpenters, and plumbers and pipe fitters. And again, looking at the top 3 lead violations from OSHA, it was again lack of initial exposure assessment, lack of interim protections for certain defined tasks, and then provision and use of protective work clothing. So in the lead standard, there's actually a clause that says until you know what the exposures are, if you're performing these listed tasks, abrasive blasting, welding, cutting, torch burning, you're supposed to presume that the exposures are above the PEL, and they give you a working range of exposure to provide your respirators for until you can get your engineering controls in place. So apparently people aren't complying with that section of the standard. So I'm kind of break this up into overview of health hazards, a little bit about industrial hygiene and how we control hazards, and then some case studies. And so since it's a long presentation, I just wanted to give you guys a chance to have any questions or comments, or does anyone have any, what are some of the primary occupational health concerns you guys might have? If I just picked on somebody, like, I don't know. Let's see, how about you in the aisle with the blue striped shirt? What would be some occupational health concerns you might be interested in? Not to put you on the spot, but do you see anything that in your business? Does anyone else got anything that they see very often they want to talk about? Yeah, go ahead. I mean, that actually still is an issue, and in fact, cadmium is a concern with solders, and probably maybe more so now, I think. And there is a cadmium OSHA standard, so that's something that's kind of overlooked but could really be an issue. So thanks for bringing that up. That's a good example of another health hazard. Anyone else? Yeah. Yeah, asphalt fumes are a big issue. That's something we see with roofers and highway laborers more so than the operating engineers, because the laborers are right there where it's coming out of the of the trucks. I'm going to talk a little bit about this paver study that NIOSH did, which dealt with that issue. Anybody else want to say anything? Okay, so in terms of industrial hygiene, which is the science that we use to try to recognize, evaluate, and control health hazards, it kind of started with this woman, Alice Hamilton, who was an occupational physician, the first woman doctor at Harvard. And she did a lot of work in the lead industries and began to observe these patterns of illness. So in construction, there's really, we don't think of it as being an area where there's a lot of health hazards, but there really are a lot of different ways to be exposed in construction. One is from the task that you're performing, and that could be from in-place materials like asbestos, or it could be from materials that you're using. They could be at the site where you're at, like was mentioned, asphalt. You know, if you're on a road job and there's asphalt fumes, it doesn't matter if you're involved with that paving application, you're going to have exposure to the asphalt fumes. Or it could be that you're working by a craft that is generating a hazard that has nothing to do with your trade, which is a problem because then your employer probably hasn't prepared you with the protection you need for that particular hazard. So just some examples of that, and unfortunately these aren't from the highway industry, but in general construction. And this is a roofing operation in Philly where on one job the guys are tearing off the old asphalt material, so they got the particulate dust from that. And then after they tear off the old roof, they're putting down this single-ply roofing system which uses an isocyanate-based adhesive. And the isocyanates like MDI, TDI, and so on, they are respiratory sensitizers, so that workers who get exposed to it and sensitized, they can't really be around it without having like something similar to occupational asthma or respiratory asthma effects. And NIOSH actually came out on and did a health hazard evaluation in Philly several years ago, and they looked at maybe a crew of 7 to 10 guys, and these were relatively young guys. You know, most of them were 40 or younger, and they found one case of occupational asthma in that crew, which is pretty high, you know, for a crew that small to see that. Just some examples of site or process hazards. Obviously, if you're working near this guy, you're going to be in trouble, right? Doesn't matter what you're doing. Another thing that's unique about construction, I think it's even more so in terms of highway work, is there's issues with lack of hand washing, and so things like lead, where very low levels can make you sick, ingestion becomes an issue. So if you don't have hand washing and you're smoking or eating with lead dust on your hands, then you have a significant source of exposure there. And then there's the issue of taking lead home. You know, Brad said I had youthful appearance. I appreciate that, but I don't know about the vision plan at ARTPA, but I'll take it. But anyway, this is a picture of me when I started in construction. No, not really. Now, that's actually a picture of my daughter when I was working construction, and I was working the night shift, and I was taking a nap that afternoon, getting ready to go to work the next day. And when I woke up, she'd set up a little tent in the house and had my hard hat on and my tool pouch on. And at the time, I was actually working at a copper smelter, so you know there was arsenic and dust that she shouldn't have been around. But at the time, I didn't know any better. So there is this concern about take-home hazards. And again, in highway work, the lead dust issue is huge for that issue. And there have been some studies that have shown elevated blood lead levels among the children of construction workers when compared to neighbors whose parents don't work in that industry. And this looks pretty primitive, but this is a hand washing station that was set up in New Jersey, and even getting that out there was a big deal and required a lot of push from the Department of Transportation to mandate that it be there and to verify it's provided and so on. So that's actually a success story there, and something you don't see on all construction jobs. Just some other general classes of health hazards is a lot of physical hazards: noise, vibration, ergonomics, heat stress, radiation, chemical hazards like the vapors, particulates, gases, and then there's also biological hazards like legionnaires and bird droppings and things like that. Some major physical hazards that I'm sure you guys are aware of include the ergonomics, like in this case where they're pouring concrete, and in this case tying the rebar mat and doing a lot of continual bending. Noise is a problem for just about every trade in construction, and they say that the average 25-year-old carpenter has the hearing of a 50-year-old. And there's something in the neighborhood of 3,500 powered hand tools in use in construction. And so you've got the hand tools that are being used, and then you also have all this background noise like the generators, the compressors, the heavy highway equipment, and that kind of thing. So you've got all that background noise level too. And this is just an example of something as common as a circular saw. Its measurements are in the area of 93 to 100 decibels, and the OSHA PEL over 8 hours is 90 decibels. So that's really loud. And you figure if someone's holding it in their hand, it's very close to the ear. So a program that's underway at NIOSH under the direction of a guy named Chuck Hayden in Cincinnati is looking at the use of state or city and state agencies for kind of federal agencies for driving purchase of quieter equipment. And in New York City, there's some programs in place that require that contractors look for quieter noise equipment or quieter construction equipment when they're making purchases. And it's kind of hard to read that, but if you want to get in touch with Chuck, his email address and phone number are in there, and there's actually a database where you can go and look at specific pieces of equipment and see what kind of sound levels are associated with it. And I guess Brad will be putting this out too in the back, so if you don't get it now, then there'll be a chance to get it later. One of the bigger issues really in construction, in addition to the vapors and so on, is the particulate hazard, that, you know, just the fume and dust and things like that. And some examples of that are, like we talked, was the silica from the blasting, from masonry work, from road work, grinding, chipping, welding fumes, metals, asphalt fumes, and diesel fumes. And for some of the metals, there's comprehensive OSHA standards, which is the case for lead, cadmium, arsenic, and now for hexavalent chromium. But for other metals which are just as hazardous, like nickel, associated with lung cancer, manganese, which is associated with neurological effects, and beryllium, these are also very hazardous agents, but there are not standards in place now. They do have permissible exposure limits, but not comprehensive standards to follow. And these are just some of the issues with welding fumes: manganese, hexchrome, and nickel with stainless, and then respirable fume. How many of you see much welding or thermal cutting in the jobs that you're involved in? Okay, a few, not so many. All right. So I won't spend much time on this, but just so you know, the source of metal fumes in welding comes from the base metal, but most of it actually comes from the electrode. Also, the coatings are a source of hazards, and then the flux that is either wrapped around the electrode or inside the electrode in the case of flux cord. You know, one of the things that's a real issue in construction is confined space hazards, and this would be like in Jennifer's presentation, where 5% were injured or killed from exposure to hazardous agents. This would be the kind of scenario where you have workers who go into a confined space and there's elevated solvent vapors or lack of oxygen, and it can actually be a fatal outcome, and often is. And I was surprised when I started working with the painters to find out that they have to actually go inside these towers and paint for corrosion issues, which obviously is a big confined space hazard. And an example of this is a chiller unit at a casino in Atlantic City in one of the interstitial floors. And back in 1999, there was a painter that was working inside that tank with his apprentice. It was a Friday evening, and they had been applying a paint coating, and it was getting late in the day, so the journeyman painter said to his apprentice, just, you know, go on home, I'll finish this up. And the guy never makes it home, and so his wife, you know, gives him some time, figures maybe he had a beer after work, but then like 2 in the morning, he's still not home. She calls the police, and they notify the fire department. The guy's dead inside that tank. And what had happened was there was xylene in the paint, and as they applied it to the walls, it was all off-gassing into that space.